Okay, let's see what are the characteristics of bonding molecular orbitals. So, it is the probability of finding the electron in the internuclear region of the bonding molecular orbital is greater than the combining atomic orbitals. That is, if we take um, atomic orbitals, in atomic orbitals there is also probability of finding electron. So, if we check a molecular orbital, that is bonding molecular orbital, the probability of finding electron in the internuclear region, that is, if you take an atom, there is a distance between two nucleus of the atom. For example, if you take two atoms, it's one atom, and we know in the center there is a possibility, there is nucleus, and we are saying the electrons are revolving in the orbital. So if we take one nucleus, one atomic orbital, so we can call it as an atomic orbital also. If we are taking another molecular orbital, they will combine each other and form. So it should be same size. So here will be nucleus, in the center will be nucleus, here also nucleus. So finding electrons, the probability of finding electrons here, if we take the internuclear axis, here will be the probability of finding electron will be more compared to the position. There will be probability of finding electron more. So the electrons present in the bonding molecular orbital result in the attraction between two atoms. Then the bonding molecular orbitals has lower energy compared to the atomic orbital which are found. That is, if 1s and 1s will combine to give sigma 1s, the sigma 1s having less energy compared to 1s orbital and 1s atomic orbital. Why? Because due to the attraction, there is attraction between this, so due to this the stability will be more, and they are formed by the additive effect of the atomic orbitals. That is additive effect, that is the amplitude. For example, psi a, it is the amplitude, psi b, so it is formed by the addition of the wave functions, and they are represented by sigma, pi and delta. We can represent it is in sigma, pi and delta. If s orbitals are combined to form give sigma, if p orbital that is pi, if d that is delta. Then we'll see the characteristics of anti-bonding molecular orbitals. The probability of finding electron in the internuclear region decreases because this is anti-bonding. So the probability of finding is internuclear region will be less. That is, electron position will be probability of finding electron in the internuclear region will be less compared to bonding. And the electrons present in the antibonding orbital result the repulsion. We know in bonding it is attraction, in antibonding it is repulsion. They will repel each other. And the antibonding molecular orbitals have higher energy because due to the repulsive force, if there is a repulsive force, it will be unstable. So the higher energy compared to bonding, and it is formed by the is formed by the subtraction of the amplitude, that is wave function, and it can represent by the letters sigma star, pi star and delta star. Then why antibonding orbitals have lower higher energy? Because there is a repulsion. There is a repulsion between, this is because of the electrons in the orbital are attracted by the nuclei in the case of bonding, but in the case of antibonding they are repel each other. That's why it has always high energy. And here a tabular column is given based on the differences between bonding and antibonding. that all we have discussed already. If you take the bonding orbital, it has either it is formed by positive side of atomic orbital and positive side of another atomic orbital, either by negative part or negative part. It should be same, but in the case of antibonding, it is by positive with negative. The lowering of the energy of bonding molecular orbital compared to the atomic orbital is known as stabilization energy, and higher is destabilization energy. So bonding molecular orbital having high stabilization energy. So we'll see features of molecular orbital theory. The atomic orbital overlap each other and to form molecular orbital. And a new type of here that we have seen in hybridization. Two orbitals combine to give a new hybrid orbital. So the old property will remove from that. Similar to this, two molecular atomic orbital combine to give molecular orbital and identity and give a new product, molecular orbital. And the electrons in the molecules are filled in the new energy state called molecular orbitals, similar to these electrons in an atom. That is, it is similar to compared to in an atom. For example, it should first fill 1s, then 2s, etc. Similar to this in molecular orbital, molecular orbitals are sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. It should fill in that order. Then the probability of finding the electron distribution molecular RNA group nucleus given by molecular orbital. Why we need this molecular orbital? Molecular orbital help us to find the distribution of electron and finding where will be the electron in an atom. And the two combining atomic orbitals should possess energy. The energy should be same between the atomic orbital, that is 1s and 1s, not 1s and 2s. And the number of molecular orbitals formed is equal to the number of atomic orbital combines. That is, if two atomic orbital combines, will get 2 molecular orbital. If 3, will get 3. If 4, will get 4. And the shape of molecular orbital formed depends upon the shape of the combining atomic orbital. If it is S and S, that is sigma. It is P and P, it is pi. That we can see in next this. And according to the molecular orbital theory, the filling of orbitals takes place according to the following rules. So you have to recollect the rules, that is Aufbau principle. That is, molecular orbitals are filled in the increasing order of energy levels. That is 1s, 2s, 2p, 3s, 3p. So molecular orbitals also filled in this order. And Pauli's exclusion principle. So in an atom or a molecule, no two electrons can have the same set of 4 quantum numbers. That is our principal quantum number, azimuthal quantum number, all quantum numbers should be different. And Hund's rule of maximum multiplicity. Then pairing of electron does not take place until all the atomic or molecular orbitals are singly occupied. First it should be singly occupied, then only the pairing will occur. So in next class we'll see how a molecular orbital will form. We will see some examples, then this idea will be clear. But before going to this, you have to know what are bonding orbital and antibonding orbital. So it is an introduction part. We'll see how to draw the molecular orbital structure of different compounds on different molecules. Okay, thank you.